We need to write the number represented by the blocks below. So we can see that here we have ones, tens, hundreds, and we also now have these blocks here, which are thousands. And the way to think about a thousands block is to imagine 10 of these hundreds blocks stacked on top of each other, because 1,000 is the same as 10 hundreds. So to write our number, we can count how many of each block we have. Here we have 6 thousands, we have 8 hundreds, we have 9 tens, and we have 6 ones. So we have the number 6,896. Now here we have 4 thousands, 3 hundreds, and 5 tens. But we don't have any ones, so we need to write a 0. And that's important because that makes the number 4,350. But if we didn't have this 0 here, we would have the number 435. But that would mean that we had 4 hundreds, 3 tens, and 5 ones. So we need this 0 in our ones as a placeholder to give the other digits the correct value. Now here we have 6 thousands, we have 2 hundreds, but this time we don't have any tens or ones, so we need to write 2 zeros to make the number 6,200. Here we have 2 thousands, we don't have any hundreds, so we need to write a 0 as our hundreds digit. We have 3 tens, and we don't have any ones, so we need to write another 0 to make the number 2,030. And finally, for this number here, we have 6 thousands, we don't have any hundreds, we don't have any tens, and we have 6 ones, so we have the number 6,006. We need to write the numbers below in digits. So here we have numbers written in words, and we can see that in each of our numbers we have the word thousand, and that tells us that our number will be at least 4 digits. So first we have 4,825. So we can write 4 as our thousands digit, and then we can write 825 as 825. Now we have 9,200, so we can write 9 as our thousands digit and then write 200, that's 200. But now for these numbers, it gets a little bit trickier. We have 8,018, so we can write 8 as our thousands digit, but now to write the number 18, we need to use 3 digits, because after our thousands digit, we need digits for our hundreds, tens, and ones. So we need 3 digits after the 1,000. So for 18, we need to write that as 018, so with a 0 as our hundreds digit. And now we have 5,005. So we can write 5 as our thousands digit, but now we need 3 digits after the thousands. So to write the number 5, we need to write 005, so that we have 3 digits after our thousands digit. Notice for these first 2 numbers, we had a comma after the word thousand, but for these last 2, we didn't. And that's because for these first 2 numbers, our digit after the thousand was not a 0. So here we had 800s and here we had 200s. But for these numbers, we didn't have a comma after the word thousand, because for these numbers, we didn't have any hundreds in our number. So the comma separates thousands and hundreds. So if you see a number written in words without a comma after the word thousand, that's a clue that our hundreds digit will need to be a 0. We need to write the numbers below in words. So we can see that all of the numbers that we have here have 4 digits. And the first digit in a 4-digit number tells us how many thousands we have. So here we can see that for this first number, we have 1 as our thousands digit, so we can write 1000. Then we can look at the last 3 digits of our number, and we already know how to write 3-digit numbers in words. So we can see that here, because we have 483, we can write 483. Now for this number here, we have 3 as our thousands digit, so we can write 3000. Then we look at the last 3 digits of our number. This time we have 072. So this 0 tells us that we don't have any hundreds in our number. So we can just write and 72. Now notice for this first number, we wrote a comma after the word thousand, but for this question that we've just done, we didn't write a comma. Instead, we wrote the word and. Now that's because when we write a number in words, the comma separates the thousands and the hundreds. But for this number here, we didn't have any hundreds. We had a 0 as our hundreds digit. So rather than a comma after the word thousand, we just wrote and then the rest of our number. But when numbers are written in digits, even if the hundreds digit is a 0, we still usually have a comma to separate the thousands and the hundreds. But not always. Sometimes you might see a 4-digit number which doesn't have a comma or space to separate the thousands and the hundreds. But because you know that we can count ones, tens, hundreds, and then thousands, you know how to find the thousands digit of a number. If it's a 4-digit number, the thousands digit will be the first digit. Now let's look at this number here. We have 3 as our thousands digit, so that's 3000. Then looking at the last 3 digits, we have 300, so that's 300. Our number is 3300. And for this last number, we have 4 and then a comma, so that's 4000. But then, looking at the last 3 digits, we have 002. So we have zeros in our hundreds and in our tens. So we can just write and 2 to give us the number 4002. Again, remember, if we have 0 in our hundreds, then rather than writing a comma after the word thousand, we need to write and then the rest of our number. We need to write the digit in each place value. So remember, we count place values from the right. So first we have our ones, then our tens, hundreds, and thousands digits. At least that's for whole numbers. With decimals, we need to remember to count place values from the decimal point. But for whole numbers, we can count from the end. So remember ones, tens, hundreds, thousands. So first, we have the number 4593. So the thousands digit is a 4. Remember, if we have a 4-digit number, the thousands digit will be the first digit. Then we have our hundreds digit, so that's a 5. Our tens digit is a 9, and our ones digit is a 3. Now we have 4809. The hundreds digit is the third digit from the right, so that's an 8. The ones digit is on the end, so that's 9. The thousands is a 4, and the tens is a 0. Finally, we have 3190. So the ones digit is a 0, the hundreds digit is 1, the tens digit is 9, and the thousands digit is a 3. Now what we can do is use place value counters to represent numbers. So for 4593, we can have 4000 counters, 500 counters, 9 10 counters, and 3 1 counters. For 4809, That's 4 thousands, 8 hundreds, no tens, and 9 ones. And for 3,190, that's 3 thousands, 100, 9 tens, and no ones. We need to write the value of each digit. So first we have the number 4,529. Remember, we count place values from the right, and we have our ones, tens, hundreds, then our thousands. So the 9 is in the ones place value, so that just stands for 9. The 4 is in the thousands, so that's 4,000. The 5 is in the hundreds, so it represents 500s. And then we have 2 in our tens, so that's 20. Now we have the number 8,706. The 7 is in our hundreds place value, so that represents 700. That's 7 followed by 2 zeros, because notice in our number, after the 7, we have 2 digits. The 8 is in our thousands place, so that represents 8,000. That's 8 followed by 3 zeros, because in our number, after the 8, we have 3 digits. And then the 6 is in our ones, so that just stands for 6. Now we also have a 0 in this number, but whatever place value it's in, the value of the 0 is just 0. A 0 never has any value in itself, but zeros are important because they give the other digits the right place value. So because we have a 0 in this number, that means the 7 is in our hundreds, and we know the 8 is in our thousands. Now we have the number 8,041. The 1 is in our ones place value, it's on the end, so that just stands for 1. The 4 is in the tens, so that's 40. And the 8 is in the thousands place value, so that represents 8,000. We can show place value counters to represent these numbers. So for 4,529, that 4 represents 4,000, so we can show 4,000 counters. The 5 represents 500s, the 2, 2 tens, and the 9, 9 ones. Now for the number 8,706, the 8 represents 8,000s, the 7, 700s, the 0 doesn't represent anything at all, and the 6 represents 6 ones. Then for 8,041, we have 8 thousands, no hundreds, 4 tens, and 1 one. We need to partition the numbers below. So when we partition numbers, what we're doing is showing the value of each digit, and we usually represent a partitioned number as an addition. So first, we have 5,371. This 5 is in our thousands place, so that represents 5,000. That's 5 followed by 3 zeros, because notice in our number, after the 5, we have 3 digits. Now this 3 is in our hundreds, so that represents 300, 3 followed by 2 zeros, because we have 2 digits after the 3. This 7 in our tens stands for 70, and this 1 in our ones just stands for 1. So if we add 5,370 and 1, we will get the number 5,371. So now let's do the same for 1,735. This 1 is in our thousands, so that's 1,000. This 7 is in our hundreds, so that stands for 700. This 3 in our tens stands for 30, and this 5 in our ones stands for 5. Now 3,035. We can see that in our thousands place we have a 3, so that's 3,000. But now onto our hundreds place we have a 0. Now when we partition numbers, we don't usually partition zeros, and that's because whatever place value it's in, the value of a zero is always just zero. Zeros don't have any value in themselves, they just give the other digits in the number the right place value. So because we have a zero in our hundreds, we know that this 3 represents 3,000. This 3 is in our thousands. So because we don't need to partition zeros, we can move on to this 3 that's in our tens. So that stands for 30, and then this 5 in our ones just stands for 5. Now 8,808. This 8 in our thousands stands for 8,000. We have an 8 in our hundreds, so that's 800. We have a 0 in our tens, so we don't need to partition that. And then we have an 8 in our ones, which just stands for 8. So let's take a look at the numbers we've partitioned a bit more closely. First, we partitioned 5,371. So we knew that this 5 was in the thousands, so stands for 5,000. This 3 in our hundreds, we can show 300 blocks. This 7 is in our tens, so we can show 7 tens, and this 1 in our ones just represents 1. We can also show the partition using place value counters. So this 5 in our thousands means that we can show 5,000 place value counters. We can show 3 hundreds, 7 tens, and 1 1. And we'll be using place value counters quite a lot, so it's good to get familiar with the representation now. Then we have the number 1,735. So that's 1,000, 7 hundreds, 3 tens, and 5 ones. Or using place value counters, we can show 1,000, 7 hundreds, 3 tens, and 5 ones. Then we had 3,035. So using base 10 blocks, we can show 3 thousands. We don't show any hundreds, we show 3 tens and 5 ones. Or using place value counters, there's 3 thousands, no hundreds, 3 tens and 5 ones. Our last number was 8,808. So for this 8, we can show 8,000 blocks. For this 8 here in our hundreds, we can show 800 blocks. We don't show any tens, and then we just need to show 8 ones. So that's 8,808. Or using place value counters, we can show 8 thousands, 8 hundreds, no tens, and 8 ones. So first, we have 3,528, and we're comparing that to 2,972. Now when we're comparing numbers, we start by comparing the larger place values first, so the place values furthest to the left. So here, because this number has 3 thousands and this number only has 2, we know straight away that this first number is the larger number. Now we have 4,922 and 4,099. Again, we need to remember to compare larger place values first, so here that's our thousands place value. But both numbers have 4 thousands. So what we do is go to the next place value column along and compare the hundreds. Here we can see the first number has 9 hundreds and the second number doesn't have any. So again, this first number is larger. Now it doesn't matter that this second number has 9 tens and 9 ones, because even those taken together are less than just 100. So because this first number has more hundreds, we know that it must be larger. Now 4,722 and 4,771. So we start by comparing the thousands, but because they're the same, we move along to the hundreds. Now here, they both have 7 hundredths. They both have the same number of hundreds, so we move along to the tens, and because this second number has more tens, we know that this number here is the larger number. And now we have 5,096 and 5,093. So here the thousands are the same, the hundreds are the same, the tens are the same, so we just go all the way along to the ones, and because this first number has more ones, we know that it must be larger. Now here we were comparing numbers with the same number of digits, but when we're comparing whole numbers, it's useful to remember that if a number has more digits, it will be larger. But let's take a closer look at some of these questions. So for this first question, we were comparing 3,528, so there's 3 thousands, 5 hundreds, 2 tens, and 8 ones, and we were comparing that to 2,972. Now we saw that because this first number had more thousands, it was the larger number. Now it didn't matter that this second number has 9 hundredths and the first number only has 5, because you remember you need 10 hundredths to make just one extra thousand. So if a number has more thousands, it doesn't matter how many hundreds, tens or ones you have, the number with more thousands will be larger. We could also show place value counters, and we can see that because this first number has 3,000 counters, it's larger than the second number, even though in the second number there are more hundreds and more tens. Then we had 4,922 and 4,099. So the first number was larger because that had more hundreds. It doesn't matter about all these tens and ones, because tens and ones are much smaller than hundreds. And again, we can show the place value counters, and again we can see here, because we've got more hundreds, we know the first number is larger. Then we had 4,722 and 4,771. So this number was larger because it had more tens, and we can see that with the place value counters as well. And then for our last question, we looked at 5,096 and 5,093. So because both numbers had 5 thousands, 0 hundreds and 9 tens, we looked all the way across to the ones, and we could see that this first number was larger because it had more ones. We can see, if we look at the place value counters, the only difference here is that this first number has 3 more ones. We need to write the numbers below in order from smallest to largest. So in our first group, we have 595, 9,595, 9,559, 5,595, and 5,955. So remember, when we're comparing numbers, we start by comparing the larger place values first, which here is our thousands. So if we highlight our thousands digits, we can see that this first number, because it's only a 3-digit number, doesn't have a thousands digit. So really, we can imagine a 0 in the thousands. So we know that this number with only 3 digits must be our smallest number. When we're comparing whole numbers, if a number has fewer digits, it will always be smaller than a number with more digits. And that's because we can imagine zeros in the larger place values. Now, we know that because these numbers both have 5 in the thousands, but these numbers had 9, one of these numbers with 5 in the thousands will be next smallest. But because they both have the same number of thousands, to compare them, what we need to do is move across and look at the next digit along. So look at our hundreds digits. Here we have 5, but here we have 9. So this number with 5 in the hundreds will be next smallest, and then this number with 9 hundredths. Now it doesn't matter that this number has 9 tens, because remember, hundreds are larger than tens. We need 10 tens just to make one extra hundred. So now we know that one of these numbers with 9 thousandths will be our largest number. To see which is next smallest and which is largest, again we need to look to the next place value column along. But here they both have 5 in the hundreds, so we move along again and look at the tens. Here we have 9 tens, but here we only have 5, so this number is next smallest, and then this number with 9 tens is our largest number. Now we have 4,411, 1,441, 1,414, 5,111 and 444. Again, we start by comparing the larger place values, but again we can see that this number here doesn't have a thousands digit. It's only a 3-digit number, so we know that that must be our smallest number. Now we can also see that this number, because it has the most thousands, will be our largest number. And then, because this first number has 4 thousandths, but these numbers only have 1, this number with 4 thousandths will be second largest. So now, all that we have left are these two numbers, which both have 1 in the thousands place. So, we move along and look at the hundreds. They both have the same number of hundreds, but when we look at the tens, we can see that this has 4 tens, but this number here only has 1. So this is our next smallest, and then we have this number here. Now, to help us understand what we're doing when we compare numbers, let's look at the representations for the numbers that we've compared. So for our first group, our smallest number was 595. So there's 5 hundreds, 9 tens, and 5 ones. Our next smallest was 5,595. Then we had 5,955. Then 9,559. And then our largest number was 9,595. Then, for the second group of numbers, our smallest number was 444, then 1,414, then 1,441, 4,411, and then our largest number was 5,111. We need to round the numbers below to the nearest thousand. So first, we have 2,392. Now because we're rounding to the nearest thousand, we need to find our thousands place, which in a 4-digit number is always the first digit. Now what I like to do is highlight or circle the place value that we're rounding to. And then what we can do is underline the digit to the right. So because we're rounding to the nearest thousand, we can underline our hundreds digit. Now remember, with rounding, if it's 4 or less, we round down. So here, because we have a 3 in the hundreds, we're rounding our thousands down. And when we round down, the digit in the thousands, or the digit that we're rounding to, stays the same. So this 2 is going to stay a 2, and all of our other digits turn into zeros, so we get 2,000. Now here, we can see the number 2,392 on a number line, and we can see that it's closer to 2,000 than to 3,000. But I'll come back to the number lines at the end of the video. For now, let's focus on the method. We're rounding to the nearest thousand, so we highlight our thousands digit and underline the digit to the right. This time we have a 9 in our hundreds, and remember, if it's 5 or more, we round up. And when we round up, the digit that we've circled increases by 1. So this 3 is going to become a 4 because we're rounding up. All of our other digits turn into zeros, so we get 4,000. Now we have 7,018. Again, we highlight our thousands digit, underline the digit to the right, and we have a 0. Now because that's less than 4, we're rounding down. Because it's 4 or less, we round down, so the 7 is going to stay a 7. All of our other digits turn into zeros, so we get 7,000. And finally, we have 5,544. We highlight the place value, underline the digits to the right, and because it's a 5, if it's 5 or more, we round up. And that means that this 5 in the thousands is going to become a 6, so we get 6,000. Now the number lines help us to understand what we're really doing when we're rounding to the nearest thousand. We can see that this first number is between 2,000 and 3,000, this number between 3,000 and 4,000, and so on. And remember, we underline the hundreds digit, and what we have with each square is an increase of 100. So for this first number line, we would have 2,000, 2,100, 2,200, 2,300, and so on. Remember, 2,500 is going to be right in the middle of 2,000 and 3,000. So here, 2,392 is just a little bit less than 2,400. But because it's less than 2,500, we know that we round down. Now for this number, 3,971, if we look at our number line, remember we're going up in steps of 100 with each square, so this number is between 3,900, which would be here, and 4,000. And we can see that it's closer to 4,000 than it is to 3,000. So that's why we round up. That's really what we're doing when we're rounding. Now this number is interesting because it's less than 7,100. So it's in fact very close to 7,000. So that's why we round down. And here we can see that because the number is more than 5,500, it's closer to 6,000 than it is to 5,000. And that's why we round up. We need to round these numbers to the nearest 10, 100 and 1,000. First, we have 4,549. Now to round to different place values, we need to remember that on the end we have our ones and then our tens, hundreds and thousands digits. So to round to the nearest 10, first of all, we need to find our tens digit, and I like to circle it. Then, to decide whether we need to round up or down, what we do is underline or look at the digit to the right. So because we're rounding to the nearest 10, we've circled our tens and underlined our ones digit. Now when we're rounding, if the digit that we've underlined is 5 or more, we need to round up. And here we have a 9, so we're rounding up. That means that this 4 is going to become a 5, because when we round up, the digit that we've circled increases by 1. So the 4 becomes a 5. Digits to the left stay the same, and digits to the right, so this ones digit, turns into a 0. So that gives us 4,550. Now let's have a look at this number line, because this helps us to understand what we're really doing when we round to the nearest 10. Now if I were to keep on counting up in tens, I would eventually get to 4,540, and then the next multiple of 10, I'd say, would be 4,550. And 4,549 is between these multiples of 10. Now when we round, what we're really asking is which multiple of 10 is this number closest to? Well, on a number line, we can see that it's closest to 4,550. So that's why we round up. So now let's try rounding to the nearest 100. We can find our hundreds digit and underline the digit to the right. So this time we have a 4, and remember, if we have 4 or less, we round down. And when we round down, the digit that we've circled stays the same. Digits to the left always stay the same. Digits to the right of what we've circled turn into zeros, so we get 4,500. And again, the number line can help us to understand what's really happening. If I were to keep on counting up in hundreds, I would eventually say 4,500, then 4,600. Now, when we're rounding, what we're doing is working out which of these multiples of 100 is this number closer to. Now notice in the method we underlined our tens digit, and on this number line, each square is an increase of 10. So 4,500, 4,510, 4,520, and so on. Now I've labelled 4,550 because that's right in the middle of 4,500 and 4,600. And we can see that 4,549 is just a little bit less than 4,550. So that's why we round down. That's why our number is closer to 4,500 than it is to 4,600. Now to the nearest thousand, we find the place value, underline the digit to the right, and we can see that we're rounding up because we have a 5. So that means the digit that we've circled increases by 1, so we get 5,000. Now on a number line, if I were to count up in thousands, I would say 4,000 and then 5,000, and our number is between those thousands. Now for this number line, we're increasing by 100 with each square, because in the method we underlined our hundreds digit. So we can see that our number 4,549 is in the middle of 4,500, and this mark here, if I'd labelled it, would be 4,600. But because it's more than 4,500, we can see that it's closer to 5,000 than it is to 4,000, and that's why when we're rounding to the nearest thousand, we need to round up. Now let's round 2,382. To the nearest 10, we find the place value, underline the digit to the right. We need to round down, so the 8 stays the same, digits to the left stay the same, so we get 2,380. Now, to the nearest 100, we find our hundreds digit, and we can see that we're rounding up, so that's 2,400. And to the nearest thousand, we find our thousands digit, and this time we need to round down. So the digit stays the same, so we get 2,000. Now we have 5,896. To round to the nearest 10, we find our tens digit and underline the digit to the right. So this time we have a 6, which means we need to round up. But we already have a 9 in our tens place value column. And remember, we can only have one digit in each place value. So what we need to do here is circle not just our tens digit, but the digit to the left as well. So we need to circle our tens and our hundreds together. So instead of 1 more than 9, what we're doing to round up is adding 1 to 89. 1 more than 89 is 90. So this 8 and 9 are going to change to 9 and 0, because 1 more than 89 is 90. Digits to the left stay the same, digits to the right turn into zeros, so we get 5,900. The 5 stays the same, this 8 and 9 turn into 9 and 0, because 90 is 1 more than 89, and then, as always, when rounding to the nearest 10, our ones digit turns into a 0. Now on a number line, we can see that if we were to count up in tens, we would eventually get to 5,890, and then the next multiple of 10 we would say would be 5,900. And our number is closer to 5,900 than it is to 5,890. So that's why we round up. Now let's round to the nearest 100. we can find our hundreds digit, underline the digit to the right, and we can see that we're rounding up. So this 8 becomes a 9, which means we get 5,900. So we get the same answer rounding to the nearest 100 as we did rounding to the nearest 10. So sometimes we can round to different place values and get the same answer. Now if I were to count up in hundreds, I would eventually get to 5,800, and then I would say 5,900, and 5,896 is closer to 5,900. So finally, let's round to the nearest 1,000. We can circle our thousands digit, underline the digit to the right. Because it's 5 or more, we need to round up, which means this 5 becomes a 6, so we get 6,000. 5,896 is closer to 6,000 than it is to 5,000, so that's why we round up. We use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 in our counting system. In ancient Rome, they used Roman numerals. So they represented 1 with an I, 5 with V, 10 with X, 50 with L, and 100 with C. And they combined these letters to form other numbers. So we know that I is 1, 5 is V, and 10 is X. So let's see how we can make other numbers by combining these letters. For 2, what they did was just wrote I 2 times. For 3, they wrote I 3 times. But then for 4, they did something a bit different. So we'll come back to that in a moment. Let's move straight on to 6 for now. For 6, they thought of that as being 5 and then 1. So they wrote V and then I, so 5 and then 1, to represent 6. Now for 7, they thought of that as being 5 and 2 1s, so they wrote V and then 2 I's. For 8, they thought as 5 and 3 1s, so V and then 3 I's. And then again for 9, they did something a bit different, so we'll come back to that in a moment. Let's move straight on to 11. That's 10 and then another 1, so they wrote X and then I. 12 is 10 and 2 1s, so that's X and 2 I's. And 13 is 10 and 3 1s, so they wrote X and then 3 I's. For 14, they did something different, but for 15, they thought of that as being 10 and then another 5, so that's X and then V. 16, they thought of as 10 plus 5 plus 1, so that's X, then V, then I, because 10 plus 5 plus 1 is 16. 17, they did 10, then 5, then 2, so that's X, then V, then 2 I's. 18, they did X, V, I, because 10 plus 5 plus 3 1s gives you 18. 19 we'll come back to, and then 20 is 2 10s, so they wrote 2 X's. Now you'll notice we've got 4, 9, 14 and 19. Now 4, you might think, couldn't they just write I 4 times? But in Roman numerals, they could only have 3 of the same letter next to each other. Otherwise, the numbers could just get very, very long. So what they did to write the number 4, they thought of that as being 1 before 5, 1 less than 5, so they wrote I before V. So 4 and 6 used the same letters, but when it was I and then V, that was 1 before 5, but when it was V and then I, that was 5 and then another 1, making 6. Now for 9, they thought of that as being 1 before 10, so that's I before X. Remember, they couldn't write V and then 4 I's because they could only have 3 of the same letter next to each other. So for 9, they had to do 1 before 10. Now 14, they combined 10 and 4. So 10 is X, and then 4 is 1 before 5, so that's I before V. Then for 19, they could take the 1, that's 110, so they could write X, but then for 9, they wrote 1 before 10, so they wrote XIX. The digit 1 they could just make with an X. Then for the digit 9, they had to write 1 before 10, so that's I before X. Notice they take each digit separately. So for 19, you can't write I before 2 X's. You can't write 1 before 20. You have to take each digit separately. So you take your tens digit, and because we've got 110, that's X. Then you take the ones digit, so the 9, and that's 1 before 10, so I before X. Now let's look at numbers all the way up to 100. So we know that X is 10, L is 50, and C is 100. We've already seen that for 20, they could just write 10 2 times, so they wrote 2 X's, because 2 tens make 20. Then for 30, they could write 3 X's, 3 tens make 30, but you'll notice the pattern here. Whenever you get a digit that's a 4 or a 9, you have to make it in a slightly different way. So again, we'll come back to these at the end. For now, let's work out 60. That's 50 and then another 10. So they wrote L and then X. 70 is 50 and then 2 tens, so L and 2 X's. And 80 is 50 and then 3 tens, so that's L and then 3 X's. Now 40, they couldn't write 4 X's because with Roman numerals you can only have 3 at most of the same letter next to each other. So they thought of 40 as being 10 before 50. 40 is 10 less than 50, so they wrote X before L. Then for 90, they thought of that as being 10 before 100. 10 less than 100 is 90, so they wrote X before C. So now let's write these numbers in Roman numerals. First, we have 35. So we can take each digit separately. This 3 in the tens stands for 30, so 3 tens is 3 X's. Then 5 is V. Now 72. To make 70, that's 50 and then 2 tens, so L and 2 X's. Then for 2, that's 2 ones or 2 I's. Now 27, 20 is 2 tens, so 2 X's, and 7 is 5 and then 2 ones, so V and then 2 I's. 83, 80 is 50 and then 3 tens, so L and then 3 X's, and then 3 they made with 3 I's. For 38, 30 is 3 X's, then 8 is 5 and then 3 ones, so V and then 3 I's. Now 99. Now you might think you can just write I before C, because 99, as we know, is 1 less than 100. But in fact you can't do that. What you need to do with Roman numerals is take each digit separately. So first make 9 tens and then make 9 ones. So for 9 tens or 90, that's 10 before 100. So 90 is X before C. So now that we've done this digit in our tens, we can make this 9 in our ones. 9 is 1 before 10, so that's I before X. And it has to be XCIX. You can't write 99 as 1 before 100. Instead, you have to make 90 and then make 9. So now for 29, 20 is 2 tens, and then 9 is 1 before 10, so that's I before X. For 92, 90 is 10 before 100, so X before C, and 2, we can write 2 I's. For 74, 70 is L, and then 2 X's, and then 4 is I before V, because that's 1 before 5. And finally, we have 47. 40 is 10 before 50, so X before L, and then 7 is VII, because that's 5, and then 2 1s to make 7. Now, we need to read Roman numerals, so we need to remember that I stands for 1, V represents 5, X is 10, L 50, and C 100. So first, IV is 4, because that's 1 before 5. VII is 7, because that's 5, and then 2 1s. XIX is 19, because X is 10, and then IX is 1 before 10, so that's 9. XXVI is 26, because XX is 2 tens, so that's 20, and VI is 5 and then 1, so that's 6. XXXIV is 34, because 3 X's is 3 tens, so that's 30, and IV is 1 before 5, so that's 4. Now, XXXVII is 37, because 3 X's is 3 tenths, so 30. VII is 5 and then 2 1s, which makes 7. XLI is 41, because XL is 10 before 50, so that's 40, and I is 1. XLIV is 44, because XL is 10 before 50, so 40, and IV is 1 before 5, so 4. XLIX is 49, because XL is 10 before 50, so that's 40, and IX 1 before 10 is 9. LV is 55, because L is 50 and V is 5. LXIV is 64, because L is 50 and X is 10, so if we have 50 and then 10, we have 60, and then IV 1 before 5 is 4. LXXIX is 79, so LXX is 50 and then 2 tens, which makes 70, then IX is 1 before 10, so that's 9. LXXXIII is 83, because here L is 50 and X is 10, and if we have 50 and then 3 tenths, we have 80, and then because I is 1, 3 I's is 3. XCIV is 94, because XC is 10 before 100, so that's 90, and IV 1 before 5 is 4. And finally, XCVIII is 98, because XC is 10 before 100, so that's 90, and VIII is 5 and then 3 1s, so that's 8.